All right, everyone. Well, thank you for joining our session. If Eric is in the room, I would like to just say that I could watch those bird videos all day and kind of nerd out on that. Anyway, thanks for attending our session. This is the Unseemly Unseen, Tracking Contaminants in Our Bays and Estuaries. I'm one of your co-chairs, Cheryl Gilbert. I'm with the University of South Florida College of Marine Science. I do program management there, and today I'm here in my role as the program manager for a study that looked at PFAS compounds in Tampa Bay, and you'll hear more about that later. Our speakers will be talking for about 10 minutes with 10 to 12 minutes with 3 to 5 minutes of questions. And now I'd like to introduce my co-chair who is attending virtually, and she will be introducing our first speaker. So thank you very much. Rosanna?
Hi, thank you, Cheryl. Is everyone, can you hear me okay?
Oh, Rosanna, you sound a little bit like you're underwater. Could you try that again?
Okay, I'm a little closer to the laptop, so can you hear me okay now?
Let's try one more time.
All right, testing 1, 2, 3.
Signal here? Okay.
Is that any better?
Maya, I have eyes on you, so. Okay. Hi. So I'd like to introduce my session co-chair who cannot speak right now. So Ms. Rosanna De Silva is the Water Quality Program Manager at the New York, New Jersey Harbor and Estuary Program and works on the complex and diverse issues of watershed, such as multi-state coordination on water resources and the importance and challenges of non-uniform water quality standards for shared waters. So thank you for attending. Our first speaker today is Dr. Duane DeFreeze. Many of you know him. He is the Executive Director of the Indian River Lagoon Council, an independent special district of the state of Florida, as the official host of the IRL Estuary Program and the Executive Director of the program. With the IRL being acutely impacted by so many stressors, he can offer a unique perspective on the need and impact of restoration efforts with a specific focus on innovative water technology research. So thank you. Duane?
Thank you. Good morning, everybody. This is not going to be a science presentation, but more of a call to opportunity and give you a sense of, what the world looks like from our eyes at the Indian River Lagoon. And I'm going to move really quickly through these slides because I'm going to try to give you some visual perspectives as well as some very specific guidance as we look at technology moving to the future. So as you all know, we're one of 28 national estuary programs. What many of you who are not familiar with the Indian River Lagoon is that we are a very long, narrow, shallow, compartmentalized system, micro tidal with really long residence times. And so we are exceptionally vulnerable to nutrient and pollutant loads. And you can see how narrow this system is in the watershed. And we are suffering greatly over the last 10 years from what we thought was just a temporary tipping point in 2011 with a super bloom of a nanocyanobacteria, which we hadn't seen before. And we have been having harmful algal blooms every year since, with the exception of last year, and of species that we had not seen before, including Oreombra lagunensis, the Texas brown tide. The result of this water condition, these seasonal harmful algal blooms, is that based on recent data from St. Johns River Water Management District, we've lost about 89% of our seagrass coverage. And anybody who's paying attention to the news lately knows that we've had well over 1,000 manatees die since a year ago. And many of those manatees, not all, but many, are struggling with starvation and malnutrition. So we have a system that's in trouble, and I would argue maybe one of the most vulnerable impacted systems in North America at this point. And a lot of this has to do with our infrastructure on land. And you can imagine if you're narrow and shallow that you're going to have impacts that are immediate on our shorelines. So I want to give you a sense of the scale of the challenges we're seeing and some of the opportunities that technology may provide as we move forward. And so our water challenge is big, but it's not just us, it's the whole nation. We have spent the last 40, 50, 60 years relying on old infrastructure that hasn't been adequately maintained, hasn't been adequately upgraded to a growing population. And I'm not going to go into detail, but you can track this almost biannually at a federal level, and we're in $1 trillion infrastructure deficit. And that's the conditions we would change now and not addressing the future population growth that we need to accommodate. And if you take a look at this from our lens, one of the things we wanted to do with our National Estuary Program is to get as close to a real number as cost for restoration. And so we looked at multiple lines of evidence, starting in 2016 with an economic study that was done by our regional planning councils that estimated the cost of the BMAPs in our system at about $4.6 billion just to meet the BMAP allocations. And so we took that line of evidence along with some back of the napkin kinds of calculations on 300,000 septic tanks, times 10,000 a piece if you converted them all. And we finally said, let's just collect projects. And so we have assembled projects from our 38 cities, our 7 counties. And this is where we stand right now. We have a project list that is pushing to the north side of $5 billion. And most of that is in stormwater and wastewater and septic systems and muck dredging. And the question is, how do you get there? And if we did it in 20 years and thinking about the time value of money, and anybody here who's been involved with Everglades restoration knows that you wait 10 years and add another $10 million to the cost. The fact is that $250 million a year over the next 20 years, we have never quite gotten that amount of investment. So the question I ask is, well, how do we get there? And we have taken a lot of effort to use the private sector consulting world as our partners throughout our program. We did a full financial analysis on the possibility of $250 million a year. There are some folks from the Balmoral group who are here who have been consultants, who have vetted some of our estimates. And here's the good news. Yes, there's enough money out there to do this kind of work at this scale. The bad news is, no, it may not be directed to the Indian River Lagoon. But if we had technology advancement to make it faster, make it more efficient, and to make it, targeted, that we could reduce these costs considerably. So imagine a septic system at $10,000, and you take it to 1,000 on some sort of technology advancement in the tank. You've just saved yourself a couple of $1 billion in projected costs. So I wanted to talk about kind of where we go. And the first thing and most important thing is we have to stop talking about costs as if it's just cost alone. We know that our system is valued at $7.6 billion a year. We also have 2 independent estimates that for every dollar that's used to invest in restoration, somewhere between $20 to $33 of value or asset protection is delivered. That is a tremendous return on investment. And so we have to start looking beyond just cost to long-term life cycle value. And we also need to think about where the opportunities for the clean sector is and are. And I'm going to just touch on these really quickly. without any kind of, detail other than opportunities for technology advancement are everywhere throughout everything we do at every sector. And so if we're looking at wastewater or septic conversion or toxic, dump remediation, technology has the potential to address those issues. What's kind of frustrating for me is that in wastewater treatment, most of that technology is already here. We're just not moving to that next level. The 21st century wastewater treatment plant, AWT becomes the low standard. And what we need to do is be addressing, no nutrients, no pollutants, no organic toxicants to ground or water ever, and then recycling for beneficial use. Is that possible? Yes. Is it possible today? Yes. Do we have the political will and the investment? It depends on where you are, but we need to move in that direction. If we look at new sensing technology, this is an exciting realm that I see is making our jobs better. The more data and the more we can operationalize that data with good QA, QC, makes us more efficient, smarter, and better at our doing jobs. And I want to show just a couple of projects that are funded at the state level that give you a good example of benefit. So we have been working on a project on our own, but one just recently funded is with Applied Ecology. I'm sorry. They're looking at a technology, and they have a poster over here on the wall about using, drones and remote sensing in conjunction with satellite sensing to get fine scale on harmful algal blooms. And I want to give credit to Florida Department of Environmental Protection, because they have identified this value proposition about investing in technology and then taking that technology kind of outward so we all have that availability to do our jobs better. So this is just one example. Claudia Listapad and her team are here. Take a look at this, because this is where we're headed, trying to get more data and to get that data operationalized so we can make better decisions, especially if we're in an emergency situation. Similar to this is trying to kind of take all of these data points, how do we store them? How do we share them? You saw a presentation earlier this morning about the challenges of QAP and getting information out. But taking data, to an operationalized point is a challenge, and QA/QC is part of that challenge. And then communicating it out in ways that are meaningful and effective is also a challenge that technology can help us with. We are working with partners at Storm Center Communications, also on a DEP Harmful Algal Bloom Innovation Grant. And you'll hear more about this from Dr. Chuck Jacoby this afternoon. But how do we take data and then communicate it more effectively? If everyone in our room here, had, 1 million or 2 million or 50 million data points, how do we get together and merge those data in an effective platform? So you're going to hear about that a little bit later on. And then also the technologies in communication. This morning we heard about social media, but it seems like us old guys like me, are barely keeping up with the technology innovations on communication. But having a technology to communicate and then having the knowledge of how you message in that technology is also a challenge, which brings social sciences to the table and understanding target audiences and messages and how technology integrates to do our jobs better and more effectively. And we see the same kinds of needs and opportunities with technology, but also with methodology when we look at oyster reef restoration. Or one of the big challenges we will have in the lagoon is seagrass restoration, which is not easy. And it's going to be a long, long task to get us back to where we want to be. And success is not measured in linear, operational success. It's going to be like this. We're going to have more failures than successes, hopefully learn from those failures, and hopefully get smart as we move forward and build a community of practice within restoration. So a couple of quick things I want to just share. A number of years ago, we had probably the first ever Hack an Estuary, where we had entrepreneurs in partnership with Groundswell Startups, which is an incubator, and our Economic Development Council had over 50 people and 15 teams, 36 hours, start to answer some really tough questions. And it was amazing to me that these young entrepreneurs in 36 hours came up with probably 5 out of the 15 projects could have commercialized if they had investment. We have reached out, and this is a project that's kind of still in its infancy, and we're still working on it. You know, how do you get industry connected without the bureaucracy of a national estuary program? So we've created an innovator and investor network, and we're working our way through the value proposition for those industry leaders. And technology, you know, I'm excited about it. It has great promise, but it's not a silver bullet. And I want to share these, and these are important. I'm happy to give you details if you contact me. I was in industry with a startup company in the water sector before I took this job. And I can tell you, I have vetted over 100 companies and entrepreneurs, you know, all with that silver bullet, you know, that I have a solution for you. And my rule of thumb now is I ask 10 questions. And if they can't get at least 7 of those 10, then they're not ready for prime time. Are you effective? And at the end of each question, you have to say, show me the data. Are you effective? Are you efficient? You know, do you have an outcome? You know, what's your technology supposed to be doing for us in this community of practice? Is it targeted, or is it a generalization where you kill one thing and kill everything in the water column? Is it permittable? Have you ever gotten a permit in any state, you know, or any nation? Is it environmentally safe? How do you know? Is it scalable? And that's the challenge for many of these technologies, especially in water remediation, is they work great in a laboratory. When you start to scale them to hundreds of millions of gallons, it starts to really decrease in both effectiveness and efficiency. Is it cost competitive? Is it sustainable? Do you have waste products that are worse than the situation you're trying to remediate? And lastly, do you trust your technology enough to go with a pay-per-performance contract? Because if the answer is no, then you need to step back and say, well, if you don't trust your technology enough to do pay-per-performance, maybe we shouldn't either. So imagine if we take our world in restoration, stewardship, remediation, and had the same level of investment that we do with Department of Defense through DARPA. The 2021 DARPA budget was $3.5 billion. And we all, in fact, all of our computers, a lot of that came through the DARPA Innovation Technology Program. But if we had water technology as a specific federal investment, then we would be moving transformational change within our industry, and we need to be really working hard to get that. So my last slide is this. Technology doesn't get there without behavior change. And so we have to work within our community. People need not just to want change, they need to be willing to change in order to effectively change our current status. And so if you want to contact me, if you have questions about technology, I'm wide open for any, you know, questions that you might have. Thank you.
Thank you. Awesome presentation, Duane. Do you have time for 1 or 2 questions? No? One, okay, cool. One question.
Thanks. Hey, Duane, that was a really great presentation. And I think you're right on when you talk about how we leverage all the various partners to unite to a common goal. My question, though, is, you know, we're innovation, and having done some of these R&D projects, one of the things we always run into, and I'm with Water Management District, so people have this misconception that we get permits like that. I think they actually take longer for us, but where innovation meets regulation, that's always been a challenge, especially when you move from the laboratory to the field. So I was wondering what your thoughts are on how do we overcome that barrier and use innovation in a way that's, like you said, permittable.
That is a really big problem, but it's a problem and a blessing at the same time. And so I'll use I serve on the governor's harmful algal bloom task force. And, we get updates on a regular basis. And many of you may know that Moat Marine Lab, has a high-tech laboratory that was built with legislative funding to vet technologies. When those technologies kind of prove themselves in at least some, if not all of those 10 categories, there are still permitting challenges to actually operationalize in the field. And so I think the challenge we have is to find the balance so we don't react in an emergency with a technology that hasn't been vetted, and at the same time make it easy enough when we do have a technology that has been vetted that we can deploy really quickly in an emergency situation, or if we have a unique opportunity for partnership. That is always going to be a challenge between kind of what we want to do and the important oversight that we have with regulation. But I think the way to do this is to set up a process that when you vet a technology to a certain point, then they streamline into the system and they have general permits or some conditional permit that allows for really quick deployment when you need it. We're not there yet, but I think we're making some progress.
Thank you, Duane. Okay. Our next speaker is Dr. Rebekka Larson. She's a research associate at Eckerd College who's been focusing on the sedimentological environment of Tampa Bay and beyond for over 20 years. Her presentation will focus on the impact of the Piney Point discharge event in the context of changes to contaminant or radioisotope levels in foraminifera assemblages. This work builds on baseline data from the area since as early as 1950. Dr. Larson?
Good morning, everyone. Thank you for coming. Like Cheryl said, thank you. I'm going to talk a little bit about the Piney Point discharge, but also a little bit about Tampa Bay baselines and previous work and some of those roles. This was kind of a bit of a response strategy. I do want to note it didn't carry through, but we did get funding from this from Florida DEP to help support the efforts. It was a collaborative effort with a lot of people from Eckerd College, including many undergraduate students who are participating with this research and continue to, as well as a lot of colleagues at USF to try and do more of a comprehensive response, reaction, and monitoring following the spill and some of the things we've learned to talk about today. Of course. So a little bit about the Piney Point discharge, not going to get in a lot of detail. So this happened within Tampa Bay. So it was an emergency discharge of waters from the Piney Point storage area over in the Port Manatee area in March of 2021 through April 8th of 2021. So it went into discharge into Port Manatee. There have been previous discharges from these holding areas, but mainly through Bishop's Harbor, which I'll show you in a map, which is slightly south of Port Manatee. So the waters that were discharged were noted to be slightly acidic, high in nitrogen, phosphorus, potentially having elevated radioisotopes. So these are natural radioisotopes that are in the environment. And so some of our questions as we were reacting to this was, what are some of the potential implications? Can we do some observations to look at this, and what is the potential persistent in the environment, which is why today I'm focusing on the benthic environment, but this is linked to a lot of work at USF in the water columns in fish and biology. So some of the discharge, some work by Shumin Hu from USF showed previous years in April kind of chlorophyll in the bay, some of the historical patterns. And as you go to the bottom panel, you can look at the evolution of that discharge circled in red. Coming out of the Port Manatee area in that southeastern portion of the bay. So a lot of us had worked on the BP oil spill, and we carried over a lot of the principles that we learned from that, and one of which is to have a rapid response to these types of events, to get out there. And we leveraged a lot of things with USF and Eckerd College due to our local location. Eckerd College, we had small boats, so we can go out and do water chemistry and sediment samples, and do this opportunistic sampling to really get a more integrated approach, but also the discharge as quickly as possible, and tying that with RV Weatherbird 2 from USF that went out. This included a lot of Eckerd undergraduates, and we also integrated this with some of our undergraduate courses as opportunities to teach the students to do research, but also have the students help perform the research needed to advance our knowledge of the area. So focusing in, so here we have Tampa Bay on the left, with green dots being samples taken by the Weatherbird 2 in deeper waters. We have a lot of yellow dots on there. Those are our surface grabs. And then if you zoom in to Port Manatee and Bishop's Harbor area, there's some red dots in here. This is where we took sediment cores with our sedimentation and stratigraphy course, which we're investigating to look at the historical record of these types of events and then historical baselines for the benthic environment. So we have two transects, one coming out of Port Manatee following the channel coming out of Port Manatee where that discharge came out, and then one to the south kind of coming out of Bishop's Harbor. We also sampled within Bishop's Harbor, which is a part of the Terracea Aquatic Preserve. And we did this over a time series. So looking at how these parameters change over the discharge and over time, we actually got out there fast enough to actually do some sampling during active discharge. And then we returned a couple times after to kind of look at how those parameters may have changed over those months, periods, and times. So looking at the impacts and focusing on the benthic system, but we also are collaborating with looking at fish, and Erin Pulster and Steve Murawski looking at PFAS, but also other biological impacts. So sediment, we're looking at the benthic seafloor. Some of the parameters we're looking at: grain size, reflection of energy and sediment sources, composition, carbonate and organic. We're also recently acquired a handheld XRF, so we can look at elemental components, and that plays a role going into the radioisotopes with phosphates coming out of that region and area. We also looked at radioisotopes, which have natural variability in sources in the environment, but you can also use them for sediment age dating, so going back in time to look at the past history of an area. But you can also have these from other sources coming in, potentially from the Piney Point discharge. So tying those together is looking as tracers for the radioisotopes. Can we use that for the Piney Point discharge? We also looked at benthic foraminifera, and I encourage you to see a talk at 1:30 this afternoon by Patrick Schwing. It might say Thursday, but it's today, as a benthic environmental health indicator. And so he's developing this AMBI index for Tampa Bay. So once again, radioisotopes kind of being a little bit of a focus today because it might be part of that effluent from the discharge. They're naturally occurring, often used for age dating, which we'll use on those sediment cores to recreate the history of that area using the sediments. They have natural variability in sources. They tend to be elevated in Florida from the limestones and that bedrock. So we have natural sources. Also, if you have a lot of phosphates coming in from those limestone and rocks, you can have these radioisotopes also be elevated. But our question here is, do we have the waste products and that discharge leading to elevation of these radioisotopes in this area from the spill? We're also looking at this in the sediments. We're also looking at radioisotopes in fish to see if there's any biologic uptake that might have impacts on those biologic and ecosystems. So that's a progress and in develop with USF. So fish. So looking at our transect coming out of Port Manatee, this followed the transect out of the channel. So we have sites and sediment samples from within the channel, which was as much as 40 feet deep, and then sites outside of the channel in the shallower waters adjacent to them. And we did a little bit of water chemistry since we were being opportunistic. We took a YSI out there and did some water chemistry during the actual discharge, which are the red dots. Distance on the bottom, 0 being right at the point of discharge in the Port of Manatee, and as you go to the right, distance in meters from down that channel, so as you get away from that discharge point. So we did detect lower or more acidic waters in our pH measurements in the surface waters adjacent to the discharge, and it decreased as we moved out of the channel. When we returned on the 28th, after the discharge had ceased, we could see that difference in change. But these are variables that might be worth looking into of seasonal variability or other activities at the port. Real quick note on the Benthic foraminifera. Encourage you to see Schwing. This will be Tuesday at 1:30, not Thursday. So he's looking at a variety of different indices using Benthic foraminifera to look at environmental health and creating a baseline to say when you have an impact or an event like this, do these parameters change, showing a little bit of difference in the environmental health. So a bit of a canary in the coal mine indicator. So he's developing that for Tampa Bay. Unfortunately, we didn't have a lot of these things prior, so baselines of what the environment was before the discharge. So he doesn't have anything definitive as of yet regarding those benthic foraminifera. So if we look at our parameters in the sediments, so texture, grain size, going from, this is percent mud, so lowest mud, most of it, the rest of it being sand and gravel, so coarser material. Blue dots being very low mud. We have the higher mud values are generally where we would expect them in the deeper parts of the channel system or in Bishop's Harbor where we have lower energy. So that's what we would expect naturally in this system. Composition, just looking at the organic matter with all those nutrients coming in, do we see some sort of change in organic matter? This also follows patterns that we would expect with the most organic matter in those deeper waters of the channel system, as well as the quieter waters inside of Bishop's Harbor. So nothing definitive here as of yet. Carbonate, so how much usually an indicator of marine life. We have in the middle of the bay a high carbonate, which would be expected. In the red dots next to the port manatee, that's likely associated with carbonates and dredge material from the limestone being brought up during dredging of the port in Manatee channel leading. So that's where we likely why we have higher carbonate values there. So getting into the radioisotopes, excess lead-210, this is the parameter we use to date sediments. So if we're going to do histories, these values in context are very low. So sediment accumulation there is probably very low, but these are what we would use if we wanted to date our sediment cores and will be doing in the future. The more useful one to look at this time is what's called supported lead-210. So these are things that are coming from the natural environment or maybe coming from that discharge. These values for context, usually these values based upon the sedimentology are usually the blue dots. So we have a lot of higher values in this region than we would expect for these radioisotopes. So one of the questions going forward is why? Is it associated with the discharge in these sediments or is it associated with the natural setting of the environment? So looking at those limestones, potential phosphate sources, natural sources, and then that waste product with that those elevated, why are we seeing these hotter colors? One thing, if we look back in baseline data, existing data in the sediments that are from previous studies, so starting to build back and look, what did we know about the environment before the event? Can we look for places of change? One thing we note here on the right in yellow, there's a lot of phosphate in that area in the sediments that has been measured before. This is from a study in 1992. So we have a lot of phosphates, which might be leading to those elevated radioisotopes. So these are things that we'll need to quantify better to deconvolute what's natural, what's due to industry potentially over the last 150, 10 years, and what might be due to events like Piney Point. So looking at baselines and some of those things is how do we actually define impacts of event? Well, we need to know what the system was like before the event happened to be able to do direct comparisons to define how it changed. So starting to look back for the benthic environments about baselines and understanding what exists. So we're looking at previous studies. There have been a lot of different sediment studies done back to, like Cheryl said, to the 50s. In the early 2000s, the USGS did a large-scale Tampa Bay project that had a lot of sediment studies. For sedimentology, we've got pretty good coverage for composite texture and composition, but some of the things we may need to do more data mining on or look at, hey, this is a data gap that we may want to develop further. In particular is the forams, so those biologic indices of benthic health, so we can assess how that benthic health may change during events or activities. The radioisotopes, what's those signatures? Can we define that natural baseline or industry baselines or those impacts and changes, as well as elemental composition for the bay? So for texture, for example, there's some maps compiling from the study since 1992 to 2006, so pretty relatively good coverage. Bigger dots or coarser grains. But these are places we could go back to also and say, have these changed since these studies and understand that evolution of the bay and change over time. But we can also use sediment cores. So like I said, we took our sedimentation stratigraphy class out and we took sediment cores over in Bishop's Harbor. And the sediment core going from the surface is now, as you go down core, you're going back through time. So we can look at those sediments and those different indices and say, how have they changed? Get back to before human impacts may have been occurring. What are the natural conditions that we may be striving for with restoration and conservation impacts to increase those environments, but also changes of industry that may have occurred over the last 100 years, as well as these create baselines for the impact from the Piney Point event. So this is ongoing work, including students at Eckerd College. So some of the things kind of wrapping this together, really learning from a lot of the stuff we had learned from the oil spill as well as other events is that rapid response can be very critical to look at the full impact of an event. We do have relatively high radioisotopes in the area, but we still need to deconvolute how much of it is due to the natural setting with the phosphates and that industry, also local industry may have impacted that over time versus what was associated with the Piney Point discharge. And so we're going to combine that with our XRF elemental analysis that we now have at Eckerd College, with the students going to work on that towards a thesis, also tying that in with the radioisotopes in fish for that biologic or ecological potential implications. So also those sediment cores are in progress to provide those baselines going back through time using sediment cores, but also reevaluating what our baselines are currently and where are gaps to help us better understand the environments and how they may respond to different impacts or changes over time, or evaluate the effectiveness of restoration work and which practices are actually being the most effective. So better baselines to be able to look at the Piney Point discharge, other discharges into the bay, as well as HABs, ocean acidification, all these things, understanding where we start from to see what's most effective with where we're going. So a lot of the different types of things that we're trying to use to have a comprehensive understanding of those benthic environments. And with that, I will take any questions if we have time.
Thank you. Any questions? Raise your hand. Okay, Joe will grab there. Great, thank you.
Hi. I'm curious, what was your dating profile for your cores? What was the oldest date that you got using lead-210? And would this project, as it continues, look or seek deeper cores to maybe get older dates?
Yeah, so the preliminary lead-210 can go back about 100 years, so it's really good for anthropogenics, and if we sometimes can get to annual to decadal scale resolution. So our profiles are relatively good. We're getting some groundwater that's causing some also complications for that dating purpose. So this is work in progress, so we'll be refining that. As part of the Tampa Bay study in the early 2000s, we took over 120 vibrocores throughout Tampa Bay, which got through, back past when sea level was here. So we have those long-term contexts in those baselines. But in the Bishop's Harbor area, we'll definitely want to know that natural pre-anthropogenic into anthropogenic period. We'll go back as far in time because then we have more understanding how the system changes and responds to change over time.
Thank you.
Yeah.
Thank you, Becca. So I am going to have my co-chair, Rosanna, introduce our next couple of speakers.
Okay, hello everyone. Can you hear me now? Okay, I think I heard a yes. All right, well, thank you, and bear with us as we try to do this hybrid approach of sessions. The next presenters will all be speaking virtually. So first up is Mr. Andrew Barron and Ms. Siva Nunna, who are both water quality scientists at the Terrebonne National Estuary Program, and this region serves as a poster child for an impaired coastal watershed that suffers from water quality issues derived from various runoff sources. They will discuss the challenges, successes, and partnerships associated with their work in these watersheds. Andrew, take it away.
Good morning, everyone. I'm going to go first. Today we're going to talk about the watershed restoration in the Barataria-Terrebonne National Estuarine System. We're going to talk about the two impaired water bodies, Bayou Falls and Bayou Lafourche watersheds for this project. Next slide. Barataria-Terrebonne National Estuary Program is located in Southeast Louisiana. Our program area consists of the land between the Mississippi River and the Atchafalaya River Basin. Next slide. Our general goal for this watershed restoration is to improve the surface water quality by reducing the nutrient and fecal coliform pollution in our waterways. Next slide, please. I'm going to talk about the background of the project. Next slide. In this map, you can see the priority watersheds for the Louisiana. Down here, you can see the blue arrow indicates the two watersheds that we are focused that are located in the Barataria and Terrebonne basins of our program area. Next slide, please. According to the 2016 integrated report, these are the watersheds that are impaired here. You can see the blue one is the Bayou Lafourche watershed, and the yellow represents the Bayou Falls. And on the due south of the Bayou Falls watershed, you can see some of the oyster propagation sites, which the Bayou Falls water quality affects these oyster propagation sites. That's why we focused on these watersheds. Next slide, please. This map shows the three land usage in the Bayou Falls watershed. The three main land usages are the pasture land, row crop agriculture, and the wetlands. Next slide, please. This slide shows you the Bayou Lafourche watershed, which is one of the major distributary river, one of the major distributor of the Mississippi. Oh, sorry. Major distributary for the Mississippi River that starts from Donalsonville and goes to the Gulf Coast. Next slide, please. Next slide. I'm going to talk about the major causes of the impairment here. Dissolved oxygen and the fecal coliform and the nutrients cause the impairments in these two watersheds. Next slide, please. The major sources, next slide, please. The major sources of the impairment in these two watersheds is agriculture runoff, nutrients going into our waterways, and the next slide is the other one is the cattle pasture land runoff. This is one of our sampling location where the cattle get into our waterways, and you can see significant erosion in the banks there. And we are trying to put impoundments with the help of the NRCS. Next slide, please. And the other problem that we are the biggest problem that we face in our waterways is the malfunctioning home sewage systems that leak raw sewage into our waterways. So most of the, unfortunately, the broken sewage systems are the biggest threat in Louisiana as well as in the United States. So we are addressing this issue in our watershed restoration. Next slide, please. And this is also one of the our sampling sites in the Bayou Falls watershed, where we often see illegal dumping of animal carcasses and other trash. Unfortunately, in the world, we all treat the waterways, most of the people treat the waterways as the dumping places. And we are trying to put no dump signs in all these locations where we encounter this kind of trash. Next slide, please. And Andrew is going to talk about the funding stream for this project.
Hi, everyone. Next slide. So funding for the agricultural portion of this project ultimately comes from NERDA for oil spill restoration from the BP oil spill. Those funds are coming through NRCS to Ducks Unlimited. Ducks Unlimited is writing individual contracts for cost share agreements with landowners, as well as contracting with us for doing the watershed monitoring that's going to track BMPs. Next slide. Funding for the home sewage assistance program that we are doing, we're going to talk about that a little more later, is coming from the Gulf of Mexico program. And that is in both the Bayou Lafourche and Bayou False watersheds. And so that money goes down through subcontractors, and they do individual contracts with individual homeowners. So we're paying homeowners to fix their home sewage systems. And then the funds that are coming from Department of Environmental Quality, those are coming down to us to do water monitoring, education, and inspections. Next slide. So we are using a variety of tools for restoration. You know, there's only so many things you can do. We work with a large network of folks, and with that, we do these different activities such as monitoring, education, home sewage inspections, person-to-person education with homeowners during those inspections, and then we do also home sewage assistance. Next slide.
As Andrew mentioned about these tools, the first tool that we are using for this watershed restoration is water quality monitoring. Next slide, please. This is our Bayou Falls watershed. It starts in Thibodaux. We have established 10 sampling site locations. Starts in Thibodaux and goes all the way to the Lockport. And we go collect bi-monthly water sampling in this watershed for we collect the water quality data and the nutrient and fecal polyphon samples. Next slide, please. And similarly, we have established 10 sampling site locations for the Bayou Lafourche watershed as well. And keep in mind, this is the watershed down here. 300,000 people are depending as the drinking water source. That's why this watershed has a significant importance in the restoration. Next slide, please. This is some of our interns coming and helping us to collect the water samples during our water quality monitoring days. Next slide, please. These are some of the methods that we use collect during our water quality sampling days. We also use oranges to collect the velocity of the water whenever we go sampling in our waterways. Next slide, please. We also collect the grab samples for nutrient and fecal coliform analysis for all these sampling site locations. Next slide, please. The other tool that we are using in watershed restoration is the home sewage inspections. Next slide, please. During our inspections, our contractor goes door to door to the homeowners and inspects the aerated treatment units, checks the filter, and checks the motor if it is running, and checks the sedimentation tank every time. And if the filter needs to be cleaned, he cleans it up and puts it back and talks to the homeowner about it. Next slide, please. And the other tool we are using is a water quality education. Next slide, please. We talk to the school groups, various school groups and universities about the non-point source pollution, and we collect macroinvertebrates as well and talk about the biomonitoring for the watersheds. Next slide, please. Whenever we do home sewage inspections, we talk to the homeowner and educate them about how to maintain the home sewage system and how to identify if there is a problem with their home sewage systems. Next slide, please. And this is the last tool we use in our watershed restoration. It's very important. That's home sewage assistance. Next slide, please. Through this home sewage assistance program, we pay the homeowners first $1,000 of no cost share is involved. After that, whatever the cost is incurred by the homeowners, we pay up to 50% of up to the $4,000 to repair, to pump out, to fix the sewage systems. Next slide, please. And this is one of the flyers we use to distribute to the homeowners to contact our agency if they have any problems, or if they have if they want to get assistance through this program, they can contact us. So this is a flyer we distribute. Next slide, please.
All right, it's back to me again. Next slide. I'm going to be talking about the results that we've collected as part of our water quality monitoring. So the first slide here is talking about excursions, percentage of excursions for dissolved oxygen. So this is the time when the dissolved oxygen is out of compliance with its standard. And you can see that for most of our sites, it is above 50% for most of our sites, for most of the events that we go out and sample. Next slide, please. This is data for fecal coliform bacteria showing the primary contact recreation as well as secondary contact recreation. If you notice the secondary contact recreation in blue, most of those are below the 25% threshold, whereas for primary contact recreation, most of these are above primary contact recreation. This just kind of reinforces the idea that we're dealing with a very impaired watershed. Next slide. Just to kind of show you variations from year to year with regard to fecal coliform, I plotted the average fecal coliform content for fecal coliform from year to year, and you can see there's a lot of fluctuation there. Next slide, please. We conduct a variety of educational activities, as Siva mentioned: formal education, field presentations, person-to-person homeowner education, classroom, field tabling, meetings, conferences, clubs, and websites and media. Next slide. One of the most important ways we do education is person-to-person, which is involved in our inspections that we do person-to-person, home-to-home. However, from our initial inspections, please notice in red that most of our inspections are failing, like at a rate of 70% for our initial inspections. Next slide. For homeowner assistance in Bayou Falls, we've assisted 130 homes. Our goal is 244. For Bayou Lafourche, we've assisted with 50 homes, whereas our goal is 244. So we're only about halfway in Bayou Falls and only about a quarter of the way in Bayou Lafourche. Next slide. For the agricultural portion of the program, we've implemented about 260 acres in BMPs. Next slide. Most of the work that's been done here was funding in part or in full by the United States Protection Agency. Next slide. And this is our screenshot of all of our partners. You need to build a big network to do watershed restoration. Next slide. This is our contact information if anyone has any follow-up questions. Next slide. We'll take any questions if we have any time remaining.
Thanks, Andrew and Siva. I do have a question in the chat here for you guys in terms of just clarifying your home sewage systems. Are these septic systems or private connections to the public sanitary sewer systems that you guys are working in part of your assistance program?
Yeah, if they were connected into a community system, there would be no need for us to do any work, really. That would be covered under permitted system. So these are all individual home sewage systems. Most of them are ATUs, aerated treatment units. Okay, so there are still some septic systems and like even some cesspools, that's the type of system, but most of those are being upgraded. Anytime the property changes hands, they have to be upgraded to an ATU. Good question.
Awesome. Thank you so much. I believe that was, I know there's a number of questions in the chat coming to you both, but I think we have to move on just given the time. So Andrew and Siva, thank you again. Feel free to respond to some of the questions that you're seeing there in the chat. So our next presenters are also virtually Ms. Liz Balladares, who is a Community Stewardship Manager at the New York, New Jersey Harbor and Estuary Program, as well as our Lower Passaic River Urban Watersheds Ambassador. Joining her is Pamela Reilly, a hydrologist in the Water Quality and Biological Studies section of the New Jersey USGS Water Science Center. So in addition to the Passaic River being a super fun site, it is also heavily impacted by runoff from multiple sources. This presentation today will focus on the use of microbial source tracking techniques to identify potential sources of fecal indicator bacteria upstream of known sources, which may be attributed to wildlife, domestic animals, leaking sewer lines cross connection to storm systems, regrowth of disinfected wastewater treatment plant effluents, as well as other unknown sources. So to kick it off, Liz.
Thanks so much, Rosanna. I assume I sound okay. Okay.
You sound great.
Thank you. So hello, everybody. Thank you so much for that really awesome introduction, Rosanna. I think you laid the foundation of our entire project. So thank you so much. So my name is Liz Balladares. I am with the Lower Passaic River Urban Waters Federal Partnership. Like you saw, I'm joined by Pam Reilly, who's a wonderful partner at the USGS New Jersey Water Science Center. And we're both here to talk about our microbial source tracking project. And Pam has the more fun part for you all. I know you're really looking forward to seeing more about the data and some of the exciting findings and results that we were able to get from that. So she will take care of that. But I first wanted to just give you an overview about our location in case you're not too familiar with us here in New Jersey, and also kind of just provide a little bit of a background in terms of how this partnership got started. It is a project that's dear to us. It really began with just a phone call, so it's really special to us, and now it's going on to its third year. So we really just wanted to talk a little bit about that first. So again, to kind of just give you a bit more information on our location. This is the Lower Passaic River. When we say Lower Passaic, we are really talking about the lower 17-mile stretch of the Passaic River, starting at Dundee Dam in Clifton, which is this little picture you see here with the little flag, and it goes all the way down to Newark Bay. In Newark. And so, like I mentioned, this is a project that is also, excuse me, that is also part of the Urban Waters Federal Partnership. We here at the Lower Passaic, we are just one of 20 designated urban waters locations. And if you're not too familiar with the Urban Waters Federal Program, we are a national collaborative that's made up of both government and non-government agencies that are working together to reconnect communities back to their waterways, in particular communities that are economically overburdened and distressed. And so something typical that you tend to see, not just of our location, but of other urban waters locations as well, is sort of this big difference on what the urban waterway looks like, depending on where you're standing in the river. So for example, here in the Passaic, if you were to be near the headwaters of the Passaic, this is the picture that you would see, right? The headwaters of the Passaic here are shown pretty well in this picture. It looks really pristine. There are lots of areas for, there's lots of opportunities for recreation, to be able to enjoy this open and wonderful resource. However, the further down you go, there's less of that. And so And so there are little opportunities for public access. There aren't that many chances for you to get to enjoy recreation activities like fishing, for example. And I'll go into a little bit more why that's heavily tied to contamination. But this is usually something, again, that you tend to see across urban waters locations across the country. And again, we are just one of 20. So if you can just move on to the next slide. And so as a partnership, some of our goals are really to be able, again, to reconnect our communities back to their waterways. We really focus on 6 main principles. I've only added 3 here just to be mindful of time. But I think probably the most important goal of ours that's also shared by other urban waters locations is the need to reduce sources of pollution to and within the Passaic River. And so that's really something that I apologize, I'm so sorry, that gave rise to our project and something that, you know, is the main piece on why this partnership even got started in the first place. Again, we're really just interested in being able to identify where these potential sources of pollution are and work together to fill in the gaps that perhaps some of our government agencies are not able to meet quite yet. This is really where we try to fill in that gap as a partnership and try to coordinate and collaborate with our partners so that we can help address those needs that aren't being met yet. Next slide. And so we can't really talk about water quality here in the Passaic without talking about its long industrial history. Many of you are probably familiar, but the entire lower 17-mile stretch, which is considered the lower Passaic River, is a Superfund site. And so there's still stories around here in our communities that if you put a hand in the Passaic River, you're going to come out with tentacles, or you're going to come up with 20 extra fingers. And rightfully so, the community, you know, has this big perception about what the waterway is and what it looks like and what it means to them. And so a big reason why the partnership got even started in the first place, it's because of the big need to better engage the community as part of this Superfund process. And so there was a heavy need to engage the community, to do more community outreach, to do improve community engagement, especially when the remedial design was being picked to address this contamination. And so that's really what also gave birth to our partnership and our location. And now we are on the 10-year step as part of this wonderful partnership. And so something that got us thinking is, okay, you know, there's a remedy that's been picked now for more than a few years to address the contamination in the sediment. About 3.5 million cubic tons of contaminated sediment will be dredged and will be capped. You know, that's how this contamination is going to be addressed in the river. But as a partnership, we're thinking, okay, what else is out there? You know, there's this contamination that's going to be addressed, but there are other sources of pollution that are worsening the river's water quality. If you're familiar with our location, you know that we have so much great infrastructure. We have a bunch of CSOs, we have tons of runoff. You know, there are so many other factors that really are worsening the river's water quality. And so while Superfund's going to be addressing this issue of contamination on the river's bottom, you know, what else can we do to be able to say, okay, this is what we need to work on now that that issue is being addressed. And so this is what really gave rise to our project. We began talking about how else we needed to address other potential sources of contamination that other folks weren't looking at, but that maybe we could help fill in that gap. Next slide. And so again, I mentioned what those sources of contamination were. I think some of you have also probably heard of Agent Orange. That was a big reason for the contamination in the Passaic River. Agent Orange was manufactured on the banks of the Passaic River. So it's just one of the ways that that contaminated sediment, you know, came to be. But again, once that's being addressed, what else could we take a look at? So that's really what gave rise to our project, which I mentioned really just came about from a phone call. We knew that there is a lot of fecal contamination in the lower Passaic River Basin. So when we became aware that through USGS, there were going to be cooperative matching funds available specifically to urban waters locations, like I said, we really just picked up the phone and said, hey, would you like to look into this with us? So that's where really this partnership started between us, the USGS New Jersey Water Science Center, and Passaic Valley Sewage Commission, we knew that a lot of the tributaries of the lower Passaic River, such as the second and third river, as well as the Saddle River, either had lack of data or were already listed as impaired waters for our state. And so really that's what made us take a look at these specific locations in particular in trying to identify those sources. So I'll stop there. I'll let Pam take more of a deeper dive into the more fun stuff, which is the data and the findings. So she can go ahead and get started. But I'll be in the chat if you all have any questions.
Thanks, Liz. That was great. So as Liz said, we were looking at the tributaries, the Passaic, upstream of CSOs in this area. If you can see on this map, you can't really see them that well, but those red dots along the river there on the right, those are all CSOs. And they were primarily thought to be what was contributing the most to pathogenic exceedances for primary and secondary recreation, exceedances of criteria. So, but we wanted to look at what's upstream, what's coming in upstream of those, upstream of the Superfund site, upstream of the lower Passaic. So we started our study in 2020, right when the pandemic hit. So it was challenging, but really wonderful to work with these organizations. So we've been working with Liz and the Passaic Valley Sewage Commission. We looked at two rivers. The one to the north there is the third river, and the one to the south is the second river. So land use surrounding these areas are a little bit different. The third river, although urban, has a lot of recreational areas that like are corridors of the stream. The second river has known direct source inputs and has been heavily studied. The channel is cement on the bottom, really highly urbanized. So we have some differences in land use. And the third river, you'll see that it's hard to see on the screen there, but that first site, it's called TR4, is the Garden State Parkway runs right through it, and that's actually at a rest stop. And if any of you have been to New Jersey, you know what the Garden State Parkway is like. So I just wanted to point that out. The second river, that second star in from the left, has been really looked at in detail by the EPA and by the Passaic Valley, since they did in-depth studies there to kind of look at where are these sources coming from. They've taken hundreds of samples along the river. And doing so, they found illicit hookups and actually sanitary sewer line breaks. And those were remediated in 2019. So for our study, we wanted to focus on the second and then also on the third to see what was being contributed by the tribs. For our sample collection, we did the fecal indicator bacteria for fecal coliform, and we also wanted to look at different indicators for sources. So we looked at caffeine. Probably a lot of you, I can't see you, but you probably are sitting there drinking your coffee. So it's primarily consumed by humans and excreted, and has been found in urban areas in high concentrations. So we wanted to compare that to our DNA biomarkers. So we took known source samples for humans, birds, doggies, and ruminant species such as rabbits and deer, and collected samples, the known source samples, and then also water samples at each of these sites. And these sites were all sampled about 6 times over between July and September of 2020. Next slide, please. So just to dig into the results a little bit, these are our E. coli results from the second and third. The third river is in blue, and the second river is in green. And they go from upstream to downstream. So TR4 is upstream, TR1 is downstream, and the same for the second river. And so some things that we want to see here is that our criteria, our primary recreation criteria, is 126 CFU per 100 mil, and that's a 30-day geomean. So at all of the sites, that 30-day geomean was exceeded for the sampling period. And you'll see the range of E. coli concentrations varies greatly. The number of samples over the single sample maximum criteria of 250 CFU per 100 mil was also exceeded. But there's some clear sites here that we want to take notice of. So at the TR4 site, you see that it has the max concentration. That's at the Garden State Parkway site at the rest stop. And then also on the second river, you see that our second site, which is SR3, you really see an uptick in the pathogenic bacteria that continues downstream all the way to SR1. Next slide, please. So to look at some of this data, we looked at eDNA using qPCR at our USGS Ohio Microbiology Lab. Now, I'm not going to show you all the data, but I wanted to show you two sites side by side so you could see kind of this signature that we see at specific sites. So at the TR4 site, which is our most upstream site, you'll see that it's dominated by human and canine biomarkers. And then at downstream at our TR2 site, which is within a large recreation park, you'll see that you'll also see human and canine sources, but then you see a bunch of avian sources too. And in that area, they have a problem with Canadian geese. They're in the stream, they're on the stream banks. There's hundreds of them. So you can really see that kind of signature DNA difference at the sites. And that's important if you want to create BMPs in the area. Next slide, please. So for the second river, same thing, I just including two sites. On the left is upstream and on the right is downstream. So the site on the right, SR3, is where remediation efforts were done by the EPA and PVSC previously to remediate known sources and illicit hookups. So what we can really tell the difference here is you see that difference in the signature, right? So the sequences are different. You see primarily canine up at SR4. And then once you get to that SR3 point, it may show us that either those sources were not completely remediated or that there's a potential for DNA to be, some sources to be stuck in the sediment, but that there's still an ongoing problem that needs further looking into. Next slide, please. So using caffeine as an indicator, we wanted to really see how this compared to our DNA data. And what we see really is that SR3 site that has those where it was remediated, you really see that caffeine signature fairly well. And maybe here and there it's a little bit high, but not exceedingly. But it really stands out at that site where there are where there's human wastewater inputs. Next slide, please. So we decided to take this to another level in 2021 to another site. We moved to the Saddle River Basin, which is just north of our second and third rivers. And here we took a little bit of a different approach. The US EPA got involved and they ran some reconnaissance samples for us in the basin because there's not a lot of work done on this basin. So we looked at 14 sites and where EPA ran call alert for us. And from there, we really targeted our sampling approach to 6 sites within the basin to look more in depth at fecal indicator bacteria and MST. We did this over basin storm flow conditions, and that's all that's hydrograph on the right, those those black stars there, those are our sampling dates. Next slide, please.
Hello, Pam.
Yes.
If you could, we're running out of time, but if you could just wrap up, I don't know how many couple of slides you have left, but if you could try to wrap up real quick,
Sure
that'd
will.
be great.
Okay,
Thank
yeah,
you.
sure. Let me just run through these. Okay, so just this slide, our sites, here's our map of our sites. The purple sites were the recon sites, and then we have our sites to the north are all tributaries to the main stem Saddle River. Important here is the HH2, that's our Hohokus, that's downstream of our wastewater treatment plant. And then downstream, you'll see our sites, Site 6, SDR2, and SDR3. SDR3 is right at the mouth of the Passaic. So really what you see here is that geomean exceeded the criteria of 126 again at all sites, and then was high at our most downstream site, which is at the confluence. Next slide. I'm just really going to run through this slide because we're still evaluating this data, but this is the DNA biomarker signature that we saw just below the wastewater treatment plant. And what's really interesting is that this signature pretty much was consistent throughout the study at all sites. Next slide. So why is this important? Well, we can collect data and that's really fun, but working with collaboratively throughout our organizations, we can use this data to do a bunch of things. And that's to evaluate the water quality. Okay, we evaluate the water quality, but how can we change it? Can we develop site-specific actions and provide community information to potentially reduce some of these inputs to the streams? What's really helped with is that we've used this data to target investigations within hotspots. So immediate responses with our collaborators to try to reduce known source inputs. And that's it. That's all I got.
Thank you, Pam, and thank you, Liz. We'll move on to the next session. If anyone online has a question for the presenters, feel free to add it to the chat. Of course, those in the room, feel free to email Liz and Pam any of your questions after the session. Thank you.
Okay, thank you. We have one more talk. Appreciate you sticking with us. Our next presentation is from Dr. Erin Pulster, who is a research biologist at the USGS Columbia Environmental Research Center. Her specialty is assessing contamination from various sources in fish and other marine species, specifically PAH, PCBs, and PFAS. Her presentation will summarize her findings from a 2020 survey conducted in Tampa Bay looking at the concentrations of PFAS compounds in fish and the associated human health risk from consumption. Erin, take it away.
Thank you, Cheryl. I am going to be presenting some data on a study we completed in Tampa Bay this past fall. We have a manuscript in press, actually in prep. I'd like to acknowledge all of our co-authors and collaborators from the Environmental Protection Commission and the Fish and Wildlife Research Institute who helped collect samples, and of course our funding from the Tampa Bay Research Fund. Next slide, please. So for those who are not familiar with the perfluorinated compounds, they are man-made compounds that have a carbon fluorine backbone. They were developed back in the 1940s. There's actually probably more than 9,000 compounds now. And because of their carbon fluorine backbone, they're one of the most persistent compounds known to nature. Their toxicity has been known since about the 1950s. And first detected in watersheds in Ohio. And then by 2010, it's pretty much been detected in all environmental media. So it's pretty much ubiquitous now, these compounds. And but they have been phased out in both US and Europe. Next slide, please. I forgot to mention on the last slide, but most of these compounds have been used in industry, wastewater treatment plants, and consumer products. Most of the consumer products is probably where humans are exposed to most. They're in pretty much everything from nonstick pans, your furniture to prevent soil or prevent staining, and oil, water-resistant clothing. They all have PFAS. Toxicity known to humans vary from sublethal effects or low birth weight, obesity, to some cancers. Next slide, please. This is where some of the environmental sources are from. There can be local sources or long-range transport through atmospheric deposition. You can look at the ratios of a couple compounds to determine whether or not they're local or atmospherically deposited. In Florida, one of the primary usages have been through the firefighting foams, a number of military bases, airports, etc. Other sources are landfill leachates and wastewater treatment plants. Not enough coffee. Next slide, please. So what's known about PFAS in Florida? It has been detected. This is a study from 2020 on drinking water in Florida. It was first detected in firefighting foams near Jacksonville in the 90s, and now has been detected in drinking water in a number of environmental samples. The map here is indicating the levels in water. Next slide, please. Which most of the levels here are shown that these levels in water are above the health advisory level. Now you can move to the next slide, please. So there's been only a few publications on PFAS-related compounds in wildlife in Florida, dating back to the early 2000s. And there's some data from dolphins, manatees, alligator, and some fish. And they're in the low ppb range, or the parts per trillion to the parts per billion range. Next slide, please. So this brought us to our question, is whether or not PFAS compounds are in Tampa Bay, and whether or not they're a threat. So our objectives of this study were to first determine whether or not PFAS compounds were detectable in both sediments and fish, evaluate the spatial trends from Old Tampa Bay, Hillsborough Bay, Middle Tampa Bay, and Southward, and then calculate or estimate the potential human health risks from fish consumption, which all this data would hopefully help inform state officials as to whether or not fish consumption advisories need to be issued. Next slide, please. So to do this, our current research, or the research we just finished, was in Tampa Bay, split up in, again, the bay segments: Old Tampa Bay up to the north, Hillsborough Bay, McKay Bay, Mid Tampa Bay, Lower Bay, and Coastal. We collected about 17 sediment samples throughout the bay, as well as 140 fish comprising about 26 species at 28 locations. Next slide, please. These are the fish. Again, we collected about 140 muscle tissues from 26 species. These were collected both in 2020 to 2021. You'll notice that it's a range of fish that cover both recreationally important and ecologically important species. This is going to give us a good indication of the trophic web, the extent of the trophic web contamination, as well as human dietary risks to human. Next slide, please. So to do this, one, you'll see that blob of sediment. You will see that blob of sediment on each slide pertaining to any sediment results. But for the 17 sediment extractions, we basically followed an ASTM method, which basically you shook with methanol, shake, centrifuged, and then filtered, and then injected. Next slide, please. The fish mussel extractions was, again, optimized using a number of EPA and Agilent methods. This used 2 grams of mussel, homogenized, shaken, and cleaned up. There will be a fish icon on all the results pertaining to the fish. Next slide, please. This particular graph is just showing we use standard LC triple quad technology. We looked at or analyzed for 25 perfluorinated compounds. Our recoveries were very good, ranging from 72 to over 100%. Next slide, please. We then took the measured PFAS concentrations and conducted a human health dietary exposure study by calculating the acceptable daily doses and the tolerable intakes. And then we compared to those 2 available thresholds that were put out by the ATSDR and the European Food Safety Association. Next slide, please. So this is, again, the sediment results. On the bottom left graph, it is showing the PFAS concentrations going from the north to the south. The highest concentrations were found in Old Tampa Bay. The range throughout the bay were from about 37 to 3,000 nanogram per kilogram. The graph on the right is just showing by station. So this just gives you an indication of all the different levels that we found across sites. Again, it's Old Tampa Bay was the highest by Cross Bayou Inlet. Next slide, please. The profiles, this is the sediment profiles that we noticed in the sediments. Again, PFAS, instead of PFAS, refers to all the compounds. PFAS is one particular compound, was detected in 100% of the sediments. Concentrations ranged from 9 to 2,000 nanograms per kilogram. This is just that one compound again. The area close with the highest levels again were by the Cross Bayou Inlet. And the graph is basically the compositional profiles. And to really what I want you to get out of that particular graph is that PFAS is the highest compound, but at some of the locations where there were incinerators, there was another compound, fluorotelomere 6.2. Next slide, please. So for fish muscle tissues, again, this is ordered with location on the X-graph axis with the PFAS concentrations, and concentrations in the fish were much higher in the Old Tampa Bay region, and again, decreased as you went southward. Concentrations of all of the sum of all PFAS compounds ranged from 300 to 33,000. And again, the highest levels were by the Cross Bayou Inlet in Old Tampa Bay. Next slide, please. This is another graph of the profiles observed in the fish species. This is all fish species combined. PFAS, this was again, it's the black color bar there. That is again the highest compound or most abundant compound in the fish tissues, ranging from 92 to 30,000 ppt. There were slight signatures. Next slide, please. Slight signature differences. Well, first I should say there are species-specific differences, which I won't get into, but you can see there were differences in levels between stations. Next slide. That particular one is hardhead catfish, as well as this particular here, there was a different compound here, PFBS, that was found in front of the power plant. Next slide. This here is just again showing the differences by fish between sediment and fish, and they had very similar compositional profiles, with PFAS being the predominant compound. However, there were slight differences in other compounds. For instance, PFOA, another very popular compound, was less than 1% in the fish, where it was about 3% in sediment. Next slide, please. So this is a picture of, it is not 1970s wallpaper, but this is the dietary exposures in fish. And what I want you to get out of this part really is the top portion is the subchronic exposures in humans, where if they're eating 3 meals a day, if they are considered at risk. And the bottom two graphs are chronic exposures if you're eating 7 meals per week. And it's going again from left to right, Old Tampa Bay to Lower Tampa Bay. And the red line across the top is the ATSDR minimal risk level. And what you'll notice is, I should also notice the graphs on the left, both top and bottom, are for youth demographics. The graphs on the right are for the adults. And what you'll notice is that for youths less than 11, they may be at higher risk in Old Tampa Bay, whereas most of the adults eating 3 meals per week or 7 have higher risks associated with eating fish from Old Tampa Bay. And actually, when you get into the chronic exposures, Hillsborough Bay and Mid Tampa Bay may also cause elevated risks. Next slide, please. This is the tolerable weekly intake, looking at the levels developed by the European Food Safety. This is for all species combined. This one doesn't look at one compound, it looks at the combination of exposures from the PFAS, PFOA, PFNA, and PFHX, which, so it's the combination of exposures of those 4 compounds. And what you'll see on the left and the right, again, it's the youth age classes versus the adult age classes, and all for all demographics, they exceed the recommended TWI derived by the EFSA. Next slide, please. This is a tolerable weekly intake for mullet-only species. The top graph is for the youth exposure demographics, and the bottom is for adults. The red line that you can sort of see at 4.4 nanograms per kilogram of body weight is the threshold, again, put out by the European Food Safety Administration. And the point of these slides is that for all age classes, they are exceeded for that combination of exposures to the 4 compounds. Next slide, please. This is looking at fish levels compared to the Michigan fish consumption advisories. And what this is indicating is that there may be fish advisories needed in the Tampa Bay region. I would also like to point out that there is probably about a dozen or so other states that have fish advisories, but the thresholds vary from state to state and range over 3 orders of magnitude. So really need to get together with the state health officials to determine whether or not they want to issue advisories in this state and determine which criteria they want to focus on. Next slide, please. So really just the conclusions are that PFAS is in the bay. They were detected in both sediment and fish. Fish levels were an order of magnitude higher than sediments. There were profile differences by species and site. However, PFAS was the predominant compound in both sediment and fish, and that typically the concentrations also both in sediment and fish decreased from Northern Bay south to the Gulf. All of the concentrations in the edible fish tissue also exceeded available guidelines, but I wanted to make a point that although they exceeded these guidelines, these risk levels and thresholds are made to be protective. So there may not be any appreciable risk, but these are what are available today. According to if you look at the ratios of PFAS to the long chain compounds, there is an indication that there may be local contamination. Next slide, please. So moving forward, I would really like to determine the extent of the food web impacts in Tampa Bay by taking a closer look at stable isotopes and more different levels, trophic levels, and then do a more focused study looking at the recreational important species, harvestable lakes, to determine whether or not advisories are needed. Next slide, please. I think I'm out of time. So that is it. Thank you very much.
Thank you, everyone. Yes, to save time, we made the applause to the very end. So thank to our speakers. Big applause.